So in this problem, you have given mono-energetic electron beam, this energy in horizontal direction subject to horizontal magnetic field, mod 0 cos, mod 04 cos, normal to the initial direction. Estimate the up or down deflection of the beam over a distance 30 centimeter. Mass of the electron is given. This okay. So this is the kinetic energy. So kinetic energy of electron Ke is equal to 18 kilo electron volt and is equal to 18 into 10 raised to 3 into 1.6 into 10 raised to minus 19 joule, and this is equal to half mv square. So we can find the velocity from this. So we need velocity. So VE is equal to 2 times 18 into 10 raised to 3 into 1.6 into 10 raised to minus 19 divided by mass of the electron, that is given by 9.11 into 10 raised to minus 19 and root of that. So I do calculation separately, so that comes out to be 0.795 into 10 raised to 8 meter per second. This is the velocity of the electron. So we can draw a figure. So this electron beam is going and magnetic field is I suppose inward. So because of this magnetic field there is a force on the beam. So this is the direction of velocity. Magnetic field is inside. So right hand thumb rule, right. Magnetic field is inside, velocity is here, so force is upward, but electron has charge negative, so it is going downward. So electrons are not going straight, but it goes down. Okay, so by the 30 centimeter, how much is going down, that we want to find it out. 30 centimeter. So there are different techniques. I can find radius of this beam. When electron is moving in a magnetic field, it performs circular motion. So I can find the radius of that. One method is to find the radius, and it is deflected like this, so you can find theta also. And you know how to find the theta. And from theta, and this is also theta. So this is the deflection. So r minus this much part. It is possible. But when I use second approach, so this is deflected because of acceleration downward. Okay, so it is displacement, suppose in y direction. Suppose this is y direction. So y deflection in downward direction y is equal to half at square. So if you find a and t, then it is possible. Okay. So this is the distance actually, and velocity is known. So distance of velocity gives the time to cross up to this much distance. હવે વેલોસિટી વધારે છે ને, તો તમે વેલોસિટી આ ડાયરેક્શનની લો કે પછી આ ડાયરેક્શન લેવા, બહુ મોટો ફેરફાર નહીં થાય. So I take that velocity only. So velocity and distance is known, so I can write d by t square. Sorry, d by v square. And acceleration is what? Okay, acceleration, we know that f is equal to ma and f is equal to qvb. So I can write evb upon m. Understood? This is the acceleration. and this is the time. તો હવે હું બધી વેલ્યુ સબસ્ટિટ્યુટ કરી દઉં તો શું આવશે is equal to, I write here, half charge of the electron 1.6 into 10 raised to minus 19 into one velocity is cancelled out, so I write down on only B. Magnetic field is given 0.04 into 10 raised to minus 4 Tesla. It is converted into Tesla. Then distance is 30 centimeters, so 0.3 square, because square is there, divided by mass of the electron, that is 9.11 into 10 raised to minus 31, and in this figure it must be 90. Oh, sorry, some mistake is there. This is 31. It must be 31. This is wrong. This is 31. Because this mistake 31. So this is also 31. And velocity is clear calculated 0.795 into 10 raised to 8. So if you simplify all this, you will get deflection y in meter. So that comes out to be 0.3 into 10 raised to minus 3 meter. So of course it is 0.39 millimeter. 0.39 millimeter. So this is the method, or you can find this theta. This is also theta. This is theta. Theta thashe. So આને કહેવાય x. This is called r. So r minus x શોધી કાઢવાનું. r કઈ રીતે શોધવાનું? તો આપણે જૂની ફોર્મ્યુલા છે q mv upon qb. Yes, mv upon qb. બરાબર છે? તો એના મદદથી આપણે r મળી જશે, x theta b મળી જશે, અને then you can find this distance. So એ બી એક સેકન્ડ ટેકનિક છે, you can try yourself.